So yesterday we saw how we simplify rational expressions by factoring using GCF and then just canceling out common factors. So we're going to do some more of that today. The problems we're doing today are a little more complex. So let's start off with this. Let's say we have this example. 3 times a quantity, 4 minus m, over 3 times the quantity, m minus 4. And we're asked to simplify. Well, what's nice about this problem is it's already factored. Both the top and the bottom are factored. But what do we got in common? Do we have any factors in common? Well, the 3's, we can mark out the 3's. They will cancel each other out. But if you look at 4 minus m and m minus 4, those are not the same. They will not mark each other out. But what's different from what we saw yesterday, I didn't give you any like this yesterday. But today, if you notice, 4 minus m and m minus 4, those are not the same, but they are actually opposites. If you add those together, they will equal 0. So here's a little trick you can do. When you do have opposite factors, a little trick you can do is you can get them to cancel out. Because what we're going to have to do is we're going to have to pick one of them. It doesn't matter which one you pick. I normally just pick the top one. So I'm going to pick the top one. So I marked out the 3. So now on top I got 4 minus m. And on bottom I got m minus 4. Well, what I can do is I can pull out a negative 1 from the top one because these are opposites. So if I pull out a negative 1 sign, if I factor out a GCF of negative 1, that changes the 4 to negative and the m to positive. So this is really negative 1, and if I rewrote it as m minus 4 over m minus 4. And you can think of the top and bottom as being 1 times m minus 4. So now we can mark out the m minus 4's. So we end up with just negative 1 over 1, which is negative 1. So this original rational expression reduces down to just negative 1. So on today's assignment, you might have some factors that are opposites. To get those opposite factors to cancel out, factor out a negative 1. And normally just do the top one. It'll make it a lot easier. You can do the bottom, but it doesn't really matter. I like to do the top. So let's try another one. Let's look at this one. 10x minus 5 over 1 minus 2x. I want to simplify this. Well, the first step to simplify is to factor both your numerator and your denominator. So on top, we can factor out a 5. So if we pull out a 5, we'll get 5 times the quantity, 2x minus 1. On the bottom, 1 minus 2x is not a GCF. So you can just pull out a 1, and you get 1 minus 2x. Now, do we have any common factors? Can I mark out anything? No. As it's written right now, I can't mark anything out. But we saw that trick on the first one. Because look, we got 2x minus 1 and 1 minus 2x. Those are opposites. So what I could do is I could pull out, instead of pulling out a positive 5 on top, I could have pulled out a negative 5. And if I pull out a negative 5, that changes the 2 to a negative and the 1 to a positive. So really, the top, I could rewrite it as negative 5 times the quantity, 1 minus 2x. So now, I can cancel out the 1 minus 2x on top with the 1 minus 2x on the bottom, and we just got negative 5 over 1, which is just negative 5. So now it's simplified. So be aware on today's assignment, you might have to use this trick of pulling out a negative 1 to get your factors to cancel. All right, so let's try another one. Let's do y squared plus 3y minus 28 all over 16 minus y squared. So again, the first step is to factor. That's why that first day we spent just reviewing factoring. I said it's going to be important that you remember how to factor. What do we have in my numerator? Up here, this is a quadratic trinomial that has a leading coefficient of 1. So since it has a leading coefficient of 1, I can factor this if it can be factored really easily. So I'm just going to put y and y down. Now I'm going to ask myself, are there two numbers that multiply to be negative 28 and add to be 3? Multiply to be negative 28 and add to be 3. Positive 7 and negative 4. So the top factors to the quantity y plus 7 times the quantity y minus 4. Well, now let's try to factor the denominator. Well, you should notice the denominator is a difference of two perfect squares. So it factors to the quantity 4 minus y times the quantity 4 plus y. Do we have any common factors? Are there any common factors I can cancel out? Currently, as it's written, no. But we got y minus 4, and now at the bottom, we got 4 minus y. This one and this one are opposites. So what we can do is we can factor out a negative 1 from one of them. And again, I just always do the top. So I'm going to put out a negative 1 here. So if I put out a negative 1 on top, that changes. I'm going to pour it out of this expression only. I'm not worrying about this expression. I'm just leaving that alone. So if I pour out a negative 1 from this expression, that makes that y negative and the 4 positive. And you can think of that as 4 minus y if you like it. So it matches the bottom. So this 4 minus y, we cancel that 4 minus y. So what's left on top? We got negative 1 times the quantity y plus 7 over 4 plus y. And I want you to leave your answers in factored form. So I want all the answers in factored form. So what I mean by that is you don't have to, I don't want you to distribute this negative 1 throughout that. Just leave it like that. So our answer is negative 1 times the quantity y plus 7 over 4 plus y. So just to save your time, leave your answers in factor form. Don't multiply the negative 1. Don't distribute the negative 1 throughout. All right, so let's try another one. We'll call this one B. We got negative 4 times the quantity m minus 1 over m squared minus 2m plus 1. So your first step always is to factor both the top and the bottom. Well, the top is already factored, so we can't do anything with the top, so I'm just going to rewrite it. But the bottom is like the one that we just saw. It's a quadratic trinomial that has a leading coefficient of 1. So what two numbers multiply to be 1 and add to be negative 2? Negative 1 and negative 1. So the bottom factors to the quantity m minus 1 times the quantity m minus 1. Do we have any common factors on top and bottom? I do. I have an m minus 1 on top and I have 2 on the bottom. So what I can do is I can only cancel the one on top with one of the ones on the bottom. I can't mark out both of the ones on the bottom. So my final answer will be just negative 4 over m minus 1. Now let's reduce. All right, so let's try another one. Let's do this one. X squared plus x minus 20 over x squared plus 2x minus 15. Now, what you can't do, which I see every year, people just want to mark out the x squares, mark out the x. You can't do that. Okay? Can't do that. Because you can only cancel stuff out if you have factors. The top and the bottom are not written as factors yet. The top is a sum and difference. The bottom is a sum and difference. So we're going to have to try to factor the top and factor the bottom. But what's nice about both the top and bottom is they're both quadratic trinomials, but both of them have a leading coefficient of 1. So these are the easy ones to factor if you can factor it. So what two numbers multiply to be negative 20 and add to be positive 1? 5 and 4. So the top factors to the quantity x plus 5 times the quantity x minus 4. Now, what two numbers multiply to be negative 15 and add to be 2? X plus 5 and x minus 3. Now that we got both the top and bottom factored, now we can cancel stuff out if they have anything in common. They have the quantity x plus 5 in common. So those are going to cancel out, and your simplified answer will be x minus 4 over x minus 3. Now you cannot cancel these x's out. I see every year that students just want to mark those x's out. You can't do that because both of those are, the top is a difference and so is the bottom. You can only cancel when you have factors. Because if you were to factor the top, it would be 1 times the quantity x minus 4. And if you factor the bottom, it would be 1 times x minus 3. What factors do they have in common? Just 1. And you just end up with what you started with. So it's factored already. It's prime. I mean, it's not prime. It can't be reduced any further. All right, let's try another one here. Let's do this one. X cubed plus 9x squared plus 14x over x squared minus 4. So again, we're going to have to factor both the top and the bottom. Well, on top, I noticed all of these are divisible by x. So the first thing I can do to the top is I can factor out the GCF, which is an x. So the top becomes x times the quantity, x squared plus 9x plus 14. So now what I got to do is see if this can be factored again. So on top, we got x, but that blue thing I underlined can be factored again. Again, it's like the one we just saw. You got a leading coefficient 1, what multiplied to be 14, and adds to be 9. What two numbers do that? Positive 2 and positive 7. So it factors to x times the quantity x plus 2 and x plus 7. So the top, the numerator, factors to 3 factors. The bottom is the difference of perfect squares. So it factors to x plus 2 and x minus 2. Now, what factors do they have in common? X plus 2 and x plus 2. So let's mark those out. So a final answer will be x times the quantity x plus 7 over x minus 2. And again, I want you to leave your answers in factored form. So I don't want you to, on top, I don't want you to multiply the x times both of those. I want your answers in factored form. So leave your answer so both the numerator and the denominator are factored. So there's our simplified answer. X times the quantity of x plus 7 over x minus 2. All right, one last one. So let's look at this last one here. We got 2x squared plus 7x plus 3 over 6x squared plus 11x plus 4. So we're going to have to try to factor the top and the bottom. But this is going to be a little more difficult than the ones that we have done up to this point. And the reason is because we don't have a leading coefficient of 1 on either one. We got a 2 here and a 6 here. So this is why I taught you guess and check method. Okay? Because guess and check is not that bad, even though you might think it is. I'm going to start with the top one. Because remember, I'm going to be guessing factors of 2x squared and guessing factors of 3. I'm choosing to do the top one first versus the bottom one is because on the bottom we got 6x squared and 4 here. On top we got 2 and 3. 2 and 3 are prime numbers. So if there's a prime number, there's less factors. So there's going to be less guessing. So let's try to factor the top. So we're going to go straight to the factors. So we're going to guess factors of 2x squared. So we're going to put 2x and x. There's no guessing there. There has to be 2x and x because it's prime. So now we got to guess factors of 3. Well, here's where the guessing comes in. Either 1 goes here and 3 goes here, or 3 goes here, and 1 goes here. We don't know the order. So that's why it's called guess and check. And now you just gotta check it. So I'm just gonna guess the 1 goes there and the 3 goes there. So let's multiply these together. 1 times x is 1x. 2x times 3x is 6x. What do we want? 7x in the middle. Can I get 7x in the middle? Yeah, if both of these were positive. Can we have them both being positive? Yeah, because the last number is positive. So the top factor is like that. We got lucky. You don't always get lucky and guess correctly. So now we're going to try to factor the bottom. But most likely one of these factors on top will match the bottom one. That's why I always start with the easier one first. Because the bottom one, when you try to factor the bottom one, it might give you clues how to factor it from the top. So now we want to try to factor this. So again, we're going to guess factors of 2x squared. Well, I can use 6x and x. I can use 2x and 3x. But I'm going to try 2x just because this one has a 2x. So I'm going to put 2x here and a 3x over here. And now I'm going to have to guess factors of 4. So I can either use 1 and 4 or 2 and 2. Again, I don't know which one's correct. I'm just going to say 2 and 2. We'll see. So I'm going to guess 2 and 2. So now we just got to check it and see if we did this right. So let's check this. 2 times 3x is 6x. 2x times 2x is 4x. I want 11x. That doesn't turn out to be 11x. So we guessed wrong. So if I switch to 2 and 2, it's not going to change it. So we're going to have to try 1 and 4, or 4 and 1. We're trying to get 11x. Well, I know 2 times 4 gives me 8. And 1 times 3 gives me 3. And then 8 plus 3 is 11. So I'm going to put the 1 here and the 4 over here. 1 times 3x is 3x. 2x times 4 is 8x. If they're both plus, you can get 11. So there's how it factors. So does the top and bottom have any common factors? They do. I can mark out the 2x plus 1 on top with the 2x plus 1 on the bottom. So the simplified answer would be just x plus 3 over 3x plus 4. So make sure on today's assignment you're factoring everything first before you start canceling stuff out. And remember, if you have opposites, use that trick. Pull out a negative sign from the top one so that they can cancel each other out.